Hey guys, so today we're going to be going over the conservation of mass and the first three types of reactions. There are 6 types of reactions in all, but we're going to go through the last 3 next week. So, conservation of mass. This we've kind of talked about before, and it's something that you may have heard of before. Previously, in grade 9, we talked about conservation of energy. Conservation of mass is very similar. Whatever you start with, you end with for mass. So the mass of the reactants is equal to the mass of the products. So this is why when we were balancing equations, we had to have the same number of each atom on either side. I just wanted to formalize this into notes since we used it, but we hadn't really talked about it yet. Okay, now on to the first three types of reactions. So this one, the first type, is called synthesis reaction. And this is when 2 or more reactants, usually elements, join to form a compound. So we usually refer to it as A plus B reacts to give us a B, where A and B represent elements. So remember, in an equation, this arrow means reacts to give us, and that's really important. The reason why it's important is because sometimes you'll actually see this as a double-ended arrow because it will synthesize and it'll decompose, so which means that the reaction can go either way. In these cases, we are just doing one-ended arrows, but if you continue on in chemistry, I wanted to make sure that you're aware of this. So synthesis reactions can actually give you ionic or covalent compounds. So say you had Mg plus O2, that gives us MgO. Well, we have to balance this first. So Mg's right now are currently balanced, but we have this 2 oxygen and only 1 oxygen, so we have to multiply this by 2. We have 2 oxygen now, but we also have 2 magnesium, but we only have 1 magnesium over here, so we have to change that as well. So this means we have a metal element plus a non-metal element gives us a compound. So this is when magnesium metal reacts with oxygen gas and it gives us a magnesium oxide. A similar thing that can happen is if we take nitrogen, and remember nitrogen is N2 plus oxygen, and when we combine these we actually get dinitrogen oxide. Again, we have to balance this. We have 2 nitrogens, good. 2 oxygens, only 1 oxygen. Well, that doesn't work. So we have to multiply this 2 and now go back. We have 4 nitrogen now on this side, only 2 on this side. So we have to multiply that side by 2. And now we have it balanced. So whenever you see an element by itself plus an element by itself that gives you a compound, you know it's going to be a synthesis reaction. Now the next type of reaction. The next type of reaction is actually quite the opposite. It's called decomposition. And decomposition is when a compound breaks into two or more elements. So this would be AB, which is our compound, breaks down to A plus B, where again A and B are both represent elements. Again, this can be ionic or covalent. We could have our sodium chloride, which is our table salt, and break it down into sodium and chlorine. But again, we have to balance this. We have 1 Na, 1 Na, 1 Cl, 2 Cl. Oh. So we have to multiply this by 2. Now we have 2 sodiums as well. Multiply this by 2. So table salt can be broken down into sodium metal and chlorine gas by melting it. It does melt at 800 degrees Celsius. And then you also need to run electricity through it. So it's not something that we can really do at home, but it is possible to do. Covalent, what we can do is we can actually run electricity through water. I do not want you doing this at home. It is dangerous if you're not doing it properly. And the molecules will actually decompose into hydrogen and oxygen, which is super flammable. So you could run electricity through water and get hydrogen gas and oxygen gas. And again, like always, we have to balance this. 2 hydrogen, 1 oxygen, 2 oxygen. Multiply this by 2. We have 4 hydrogen, so we have to multiply this by 2. So that's what decomposition is. You take a compound and you're separating it into the 2 different elements. The third type that I want to talk to you about this week is called single replacement. So single replacement is when one element from a compound is replaced with a separate element. So this we're going to actually introduce the letter C. There are 2 different types depending on whether A is a metal or a non-metal. But the general form is if we have A plus B and C. If A is a metal, we'll get B by itself and A and C together. Because as you can see, if A is a metal, it's going to replace the metal. If A is the non-metal, when we add these reactants together, A plus B and C, that A is going to replace the non-metal. So we'll have, not B, we'll have C plus BA. So depending on what A is, that is what it will replace. If it's a metal, it will replace a metal. If it's a non-metal, it will replace the non-metal. So an example of when A is a metal. When we take aluminum foil in a solution of copper chloride, what will happen is that copper will go off by itself and we will form aluminum chloride. So again, we have to check and see if we can balance this. 1 Al, 1 Al, 1 copper, but we have 2 here and 3 here. We really want an even number for this one because we have an even number over here. So if we multiply it by 2, we get 6. We need to multiply this by 3. Now we have 3 coppers, we have 2 aluminum, and we have it balanced. I know I do the balancing really quickly, guys. Honestly, it's just a matter of practice, practice, practice. When A is a non-metal, so when we take fluorine and we bubble it through a sodium iodide solution, we get iodide by itself, or iodine by itself, and we end up with a sodium fluoride. Again, first thing we do is balance. We have 1 sodium, 2 fluorine, 1 fluorine. Have to change that. 2 sodium and 2 iodine. That one's a relatively easy one. Those are the first 3 types of reactions that we're going to look at. Next week we're going to be looking at double replacement, neutralization, which we've actually already looked at before, and combustion. This week though, you do have a worksheet about the different types of reactions, and you have your acid, base, and salts quiz. So the quiz is a Google form that is in the Google Drive. You do need to use your pseudonym, so if you don't know it from the markup date from before, send me a message and I'll send you your pseudonym. This just allows me to know whose quiz it is. I will consider allowing rewrites for this one because it's the first time you guys are doing a Google form for me. Well, I hope you guys had a great long weekend. I hope you have a great week. Don't forget to check in with me this week, sending me a message or an email. Just let me know that you're doing all right. Have a great week, guys.